we have another session by Dr. Rajesh Ingal. His title is Enhancing Smart City Initiatives Using Blockchain and Edge Computing. So, Dr. Rajesh, can you hear us?
Yes.
Yes. Okay, we
So,
can also hear you nicely. And I am Professor Muhibul Haq Bhuya of Electrical and Electronic Engineering Department of American International University, serving as a session chair of this session. And also with me, Dr. Saiful Islam from Material Science and Engineering Department of Bangladesh University of Engineering and Technology, Buet. So before the start of Dr. Rajesh's presentation, let me introduce him with his brief biography. Dr. Rajesh Ingal is a professor and head of computer science and engineering at IIT NR. Prior to joining IIT NR, he was a professor in computer science. He was a professor in computer science and engineering at PICT, Shovitri by Phule Pune University, Pune, India, and adjunct professor at Government College of Engineering, Pune. He has also served as a Senate member of Shovitri by Phule Pune University and head EDC and Business Incubation Center, head of the CE department at PICT, Pune. He has also received 2014 IEEE Outstanding Branch Counselor Award from IEEE. He is also a recipient of 2019 IEEE Region 10 Outstanding Volunteer Award in recognition of outstanding contribution and services to IEEE Pune section and IEEE Region 10. He has received his PhD in Computer Science and Engineering from the Department of Computer Science and Engineering, Indian Institute of Technology, Bombay. He received the B Engineering degree in Computer Engineering from Pune Institute of Computer Technology, University of Pune, and M Engineering in Computer Engineering from Government College of Engineering, Shovitri by Phule Pune University, India. He has also received MS in Software Systems from BITS, India in 1994. He is working as the chairman, IEEE Computer Society Pune chapter. He has served as the chair of IEEE R10 Asia Pacific Student Activities Committee, Vice Chair IEEE India Council, Branch Counselor of PICT IEEE Student Branch. He has guided more than 600 projects at undergraduate and postgraduate level. 5 students working with him completed PhD in computer engineering, and 5 students are working with him for doctoral research. He has more than 75 research articles at various conferences and journals at national and international level. So this is his brief biography. So now I would like to request Dr. Rajesh Ingal to start his presentation. Dr. Rajesh.
thank you very much, actually. And I'll just go ahead, and I think I have 15 minutes, right? So
you can take little more time because we could save some time for this session.
Okay. So, in fact, looking at the, the aim of this conference, I tried to align my slides accordingly. So I'll focus on, smart city is part of the nation. And when you talk about smart city initiatives, it's actually a smart nation building. So I'm just trying to put some point over here. What is the role of blockchain and edge computing in enhancing these initiatives? So I'll just cover a few trends quickly, which actually drives us towards this adopting of these two technologies, that is blockchain and edge computing in smart city and the smart nation development. Then I'll just say, few use cases in it. So all of us know these sustainable development goals for sure. And if you look here, we already have this, 1 second. Because we can see this 11 sustainable cities and communities. So majority of us and various projects look after and focus on this. So we have to quickly look at the focus. So if you see the focus, what is happening right now in the world is that we have more digital, more devices online, right? And there is a big prediction, which I'll show it to the next slide as well, or the current statistics as well. Then we have machine learning in the mainstream. Right? Earlier, 25 or 30 years back, AI was just a theory, but today it is a reality. and we are making use of it in day-to-day life, then devices generating more data. So we all know, right? Instead of not just human being, the devices are generating more data, sensors are cheaper, and then increased demand for low latency. Of course, most of the researchers know for sure that reducing latency is by default a research problem. And another thing which is coming in last few years is data privacy regulations. And these trends are actually driving few other technologies to be part of our day-to-day life, delivery and services. Specifically, when we talk about digital transformation of whatever area we are working in. So, in fact, if you look at it, we are surrounded by smart speakers, thermostats, light bulbs, security cameras, sensors, and more. And if you look at just the statistics in 2021, in fact, we had more than 10 billion active devices, right? So I'll just come to this another statistics point, right? Where we can just check, and it may lead per minute. You will see that after 2025, it is 152,000 IoT devices per minute will get added. And that is what is the prediction. And if you see, the question is, businesses are rushing to take advantages of this benefit. But the question is how to get the most out of this infrastructure when there are so many other issues, and they are already in place. Now, we have seen multi-tenancy and other things, utilization. Now, if you are deploying it for one particular department in our city or in our nation, the similar sensors, the same sensors can be used for multiple, goals to address multiple goals and targets. So another thing what we have to look at, these three important things, like networking is everywhere, computing is everywhere, and mobility is everywhere. And the new reality is that we used to see that data is in data center. But today, if you see, more applications are live outside the data center. And another important thing what we need to look at, focus at, is that sensitive data is located in several cloud services. The third one is that users are connecting from everywhere. And specifically in last 2.5 years, we have seen that. Now, if you want to look at these three realities, now when we talk about security, what we have seen just before some time, the very good presentation, that we talk about data in store and data in transit, but we are coming across a different scenarios. And if you look at Gartner's recent report, right, 75% of the enterprise generated data will be created and processed outside a traditional centralized data center by 2025. Now our infrastructure, our data is no more with you or maybe in the data center. Now it's a challenging thing. So there exactly the role of all this new federated learning, which is enabled by edge computing. And then what problem which we have seen just before some time, the people who know security, like I have seen one of the question just in the last session. Yeah, I mean, after completing PhD in security itself, I've also felt like that, whether I should enable my online transaction for my account or not. It's a big threat. So all this actually we need to look at, and blockchain actually plays a heavy role in that, as it was rightly said. And I'll touch upon that few parameters of blockchain, what actually play a role in making our life smarter, or smart city or smart nation development. So if you see the statistic right now, this is this year's suppose statistics. If you see last year, the total revenue was around $383 billion, right? And specifically, if you look at our like we have seen Bangladesh, India, Myanmar, now we have seen Sri Lanka. So Asia Pacific is going to be the next fastest growing region, specifically from this year to 2028. And we will see many changes happening in this area. So when we say developing, we are in the challenging area, and there actually we need to understand how to deploy technology. So 10 billion active IoT devices are already there, and we will reach 25 billion by 2030. And data generated will be something like 73 zettabytes. Of course, if you look at various different sources, you will have different figures. Now, this is from Vantage Market Research. And if you look at IDC or some other, you will get, but the trend remains same. But what important thing you should see over here, that it is the increasing adoption of maturing technologies such as AI, 5G, cloud, and edge. right? And these are all actually supporting, like 5G is supporting the driving of edge computing, and edge computing is possible because of 5G. So all these have interconnections in it. And we have already seen that sustainability goals is very much required. And that are the growth drivers, right? And more devices and sensors at the edge are collecting more data. Now, that is also challenging, where to store data, where to process data, right? And where you need that output to actually complete the loop. So there are parallelly, you can check that the evaluation of devices is also there. Of course, Moore's law is in place. People are driving it, right? So more powerful devices in terms of memory and storage are coming, and computing is now possible at the edge. So edge devices are there, access devices are there, and you have data center where actually a lot of model training and other things happening. So Gartner Hype Cycle in 17 itself said that it is, and was representing it. Now, why are we talking about it? The one important thing I would like to highlight here is algorithmic trust. So increased amount of consumer data exposure, fake news and videos, and biased AI. These all things have caused organization to shift from trusting central authorities to trusting algorithms. And that is how in blockchain, when we say smart contract, the smart contract is trusted just because of this driving force. And we write smart contract, and the smart contract decide how the transaction happens. So these are few things very, very important happening. And if you combine these things, we'll actually have multifold gains in digital transformation or making something smart. Now, the question may be asked, what is smart? Now, there can be many dimensions to it. But normally, if you ask me, normally, whatever things happen in the city, there is accident happens, we react to it. If network fails, we react to it. But if you can predict, predict what is going to happen and then elevate from that, so if you can proactively work, then actually I say it is a smart move. So algorithmic trust models ensure the privacy and security of data, provenance of assets, and identities of people and things. So this is what we have seen, and there is a hype cycle which probably may not be spent time to discuss. Now, I would like to highlight to the whole, whomsoever is attending online, or maybe I could see some few people sitting there. This is the interesting thing. Last 60 years, we need to understand the focus of the technology. I'll take only 2 or 3 minutes to tell you that we started with mainframe. We say mainframe computing. Then we have PC computing, right? And I hope you all know, you are all researchers, so you know when I'm saying this, what all things are moving. PC computing, then network computing, right? Within the intranet, basically, then we have intranet of network of intranet together. So internet computing. Then we talk about grid computing, especially driven by the high performance computing requirement, right? And then we reached cloud computing. And I still remember 2007 onward, we used to start talking about elastic computing. Now the service and deployment models together, the utility computing became cloud computing. And we wanted to push everything. In fact, the same way what we had done during mainframe, we also pushed our program to the mainframe. At the central place, we pushed our processing to the mainframe, we pushed our data to the mainframe. Same thing we are doing in cloud computing, if you look at the paradigm shift. But then what is the difference? The difference highlighted over here is that in case of mainframe, your user terminal was dumb. It was not doing anything. We had I think terminal emulator softwares which were doing. So even if you say, your institutes, triple I, or maybe IEEE, then all I will go separately, E will go separately. Assembling was done at the server, but now we have more powerful, what I say, the simple, your any device, any node, what you are carrying, maybe your mobile phone is more powerful than the mainframe at that time. Another thing is that in case of mainframe, we had limited computing facility, but now in case of cloud computing, we have unlimited facility. The question is now, why are we going for something like edge computing, right? Because in cloud computing, what has happened that we have a lot of servers and we kept it in the data center and we are pushing our data there. Now deep inside the cloud, what has happened for application, the latency is there, the propagation delay is there. And because of this, there are few disadvantages like latency, right? Then jitter, variation and delay, location unawareness, insecure data outsourcing and limited access, Like this, there are many bottlenecks which has actually not allowed many applications to be what I say viable. So there are many applications which are not possible in case of a current cloud computing scenario. So you have to have a one which is actually giving you less latency, and that is actually offered by the edge computing. And here actually typically we have seen three different models: fog computing, mobile edge computing, and cloudlets. So these are all things what is happening right now. And that's the reason we are actually seeing this cloud computing paradigm shift of last 6 decades. Now, another thing, let's understand the role of this in the smart city. First of all, let's understand the impact of maybe we have seen just now edge computing. Will touch upon that again. But now let's understand what is the impact of blockchain technology on smart cities. So now there are many categories of government activities. If you start realizing, because of course you people must have seen, the participant must have seen actually when the blockchain to be applied, when not to be applied, which are the characteristics. So that tells you, like, first is identities, self-sovereign identity of our citizens. Now it is actually an approach to digitally identify that gives individuals control over the information they use to prove that they are the to the website and other thing. It's a complete shift. In fact, if you look at who is managing our data today, now I'm doing this access and Zoom may be recording it. So Zoom has that data. When I do something in WhatsApp, the WhatsApp is recording that data. So I am, as a person, have my own identity, but my data is managed and used by somebody else. Now it is complete 180-degree shift. When I say that whatever things, when I go to hospital for checking my X-ray, whatever blood reports and everything, that data is my data. Why a hospital should make use of it? So if it is controlled by you, it is a self-sovereign identity. So smart cities leverage technology and utilize existing and plan infrastructure investment to provide a higher quality of living to the residents, a conducive investment climate for businesses, and allow maximum of resource utilization and transparency for government. That is what we actually aim when we do governance. So moment of asset of value, we would like to purchase, sale, transferring of money from one place to another place. Just before, sometime we have seen the reservations using online transaction. But one thing you should remember for sure, that nobody can stop technology, right? We have to adapt it. We have no other way. Cloud also, we have seen cloud, maybe 10 or 2007, we have seen there are many security issues with. Today also we have, but in spite of that, we are forced to make use of it. Can you show any application what we do online is not using cloud? So we need to realize that there is nothing like 100% security, right? So we have to actually see what are things, tools available with us and go further. Now you just take the example of new things which is maybe getting launched at various countries, like 5G. When you talk about 5G, you cannot have the high level of security what normally we do in networks. So we talk about lightweight security. The moment you say lightweight, it is actually telling you that is the weak security, right? So all that has to be dealt with, and we will work on it. So there are, when you talk about smart environment and smart spaces creation, we look at smart city, smart transport, smart building, smart energy, smart industry, smart health. And there are various sensor actuators, semiconductor electronics, and there are various developments what we need to look at. In the interest of time, I'll not spend and discussion on that. But let me tell you, IoT is one driving force and the basis for making smart cities a reality. And there are many advantages of that. So it is actually closing the control loop. So I might, so there are, if you look at what makes a smart city possible. So ubiquitous internet connectivity, advancement in sensor technology and reduction in the cost of sensors, advancement in low power communication technologies, and availability of cloud scale deployment and management frameworks tools. So there are many other infrastructure. You might have heard of digital twin, e-governance system, geospatial systems, and citizen government collaborative system. So like that, there are many such possibilities in case of smart city enhancement. So there, and from where you get input from all these different places, logistic, media, healthcare, and then actually use that data, maybe integrated AI model or machine learning model, right? And this is the magic of deep learning. So you can think of, and today we are talking about also transformers. So there are various applications where a respective model in AI or intelligence system may be used. Again, A2 2.2, we know it has been actually basis for all things connected. So there are many sub use cases like industrial automation, agriculture, horticulture, city farming. Now, if you go to Singapore, you know that there are vertical farms and lettuce and most of the things were imported. Now, few of the things are getting, I should not say, but it is manufactured, I should say, right? And agriculture, we are using that word now because of this newer technologies. Process automation, healthcare in hospital and home sitting. Then home and building automation. So there are many such applications where available. Now we need to understand that there are many things, specifically non-functional requirements, are taking the center stage. And because of that reason, the blockchain and edge computing will play a role. Trust, identity, privacy, protection, security, safety. And there is a role of standards in smart cities. So I might go ahead. But if you look at this, a home in the smart city. Now, many of you probably are not aware that for everything what is used day-to-day life, there is some standard available. Now, I'm just putting here the IEEE standards. There may be other standard bodies who have come out with some new standards as well. But you can think about your home itself is driven by many such standards. Now, at your place also, institute, your university, now whatever electricity you are receiving from the electricity department, now the harmonics are generated because you have printer, you have various machines. So the moment you pull and push maybe the button, so what happens? You suddenly take a lot of power. So there is a spike in it. So it generates harmonics. Now, if you do not have the controlling mechanism, you check your agreement with the service provider all over the world, it is actually governed by IEEE standard again. So there are many things what actually we need to work on in case of smart city and see that these kind of things are existing and make use of that. So there are energy management, there are various things, even in healthcare. So I've just said about digital energy management in city, then also in healthcare. So there are various standards available for biometrics and otherwise. So I will. Then enabling mobility ecosystem. So there are many standards and available. So when you actually think of developing infrastructure, it should not be only the civil infrastructure. You need to think of all these different disciplines together, and then you need to plan accordingly. Or else, suppose your university is planning a new campus. Now that campus no more just in civil infrastructure. No, it has to have a lot of other things, right? All this protocol, if you want to support backnet should be supported if you are using IoT. So it should be enabling. If you have that infrastructure, then only the smart applications running on top that infrastructure is possible. So you need to know which are things are applicable. So in the interest of time, I do not have time to go through all this. So smart rail, smart safety, transportation, electricity, and many more such things are there. Now, quickly, I'll just take 2 or 3 minutes on blockchain. So we already have seen actually in discussion, now smart city areas where the blockchain can have an impact, not just in finance, but everywhere, economy and employment, health, identity and culture, all these places we have got a role to play. Now, if you see 2021, we had 6.6 billion. In 2022, 11.7 billion. Then 2024, it will 20 billion. And by 2030, it will be $3.1 trillion utilized. So you can see that how much impact blockchain is a disruptive technology, and it's going to play a big role in it. So I'll just, the potential, I'll just skip. So there are desirable properties. So please allow me because this, so what is the value of blockchain? So transfer of value without intermediaries, benefit to the society, and new opportunities and new business models. So if you see, typically we have distribution in, so blockchain has these 5 elements, and in your application, you will make use of few of them, not just immutability property. Most of the people think immutability is the only thing, but no, it is having distribution, encryption, immutability, tokenization, and decentralization. And depending on this blockchain spectrum, today we may be blockchain complete place. By 2030, we will reach enhanced blockchain. So blockchain inspired is just most early blockchain solutions, and they lack elements like tokenization and decentralization. Now, it has only 3 components out of 5 in case of blockchain inspired, that is distribution, encryption, and immutability. And when you say blockchain complete, you have all this solution in this space includes all these 5 elements, right? With the intent of delivering on the full value proposition of the blockchain. And blockchain, enhanced blockchain, the third phase of blockchain will combine blockchain complete solution with the complementary technologies such as, I just said machine learning, different thing, artificial intelligence, machine learning, deep learning, and many more things what are coming. The Internet of Things and decentralized self-sovereign identity. So that is what we are heading towards, this enhanced blockchain stage, where it will have answers to many of our questions, what we face day-to-day life in our city. So I'll just say there are many standards available. So there are agriculture clinics, and there are many things available, and there are many places where possible. I'll just say 2 minutes into edge computing. Edge computing started way back actually in content distribution network. We keep at one place. So what is happening that reaching out to the deep inside the server there is a delay. Instead of that, what we happen, we kept a mirror at the edge. Now, because of that, the latency is reduced. But the thing is that it has added few more things like, consistency problems, and there are other problems what actually need to be solved, right? So edge computing is mainly is about location and reducing the latency. And again, the prediction of IDC, if you see, by 2023, over 50% of the new infrastructure will be on the edge. And now question may be asked, this is one thing, and I'll stop in the next 2 minutes or so. So if you see, what is the need of edge computing in this smart city applications? So one thing is very clear, application that cannot tolerate latency. So I'm just indicating that applications are not possible without an edge computing, right? So latency can be a reason for failure in case of healthcare, financial transaction, and self-driving vehicles, right? And you understand that. Application that require autonomy. We talk about, fourth revolution. So industry 4.0. So completing task with no or minimal human interaction, self-driving cars, industry 4.0. The third one is application that requires significant bandwidth. Generate significant amount of bandwidth, smart homes, smart surveillance system. These 3 things very clearly tells that, right? So taking data into the deep cloud is not the realistic solution, and you need an edge computing. So already on the Gartner and other places, you can see edge computing is there. And these are the 4 imperatives driving complete computer to the edge. Law of physics. And when you say law of physics, it is talking about actually propagation delay, right? There is a limit, physical limit, because when you want to transmit something, there is going to be a delay. So if it is in deep, your few applications are not possible. If you want to move the car within few seconds, and if you are actually expecting it to answer from the data center, which is 4,000 kilometers away, you will not get that in time. So law of economy, cost of bandwidth, and age, the physical location. What is age? The edge is the physical location where the things and people connect with the network. So there is a different thing. Then law of land, regulations, and Murphy's law. So these are various things what we need to focus on. So, laws of edge computing, we need to actually look at, and we will work on that. Okay. So defining edge computing, so here I am just telling that if you see that, instead of putting deep inside that, you can see here, reduce latency through the edge computing. And that reduced latency is the one driving force for edge computing. And there are many other applications. One more important thing is that without having connectivity also, your city can work because you have a lot of things available locally. Your model is trained and available in local devices. So even if there is not connected to the internet, you can do speech recognition, face recognition, speech translation. Your services are not disrupted. So providing computation intensive capabilities and data at the edge where there is no access to the cloud is also possible. And that is the biggest advantage of edge computing. Now, what is an edge? It depends on your definition. And these are the drivers: latency, bandwidth, privacy, security, connectivity, and local dependencies. So I'll just move further a little bit, and I'll just tell you this is the edge computing architecture. Typically, you see device edge, local edge, and the cloud edge. So when you say edge computing, it is actually not going to replace the cloud computing. Actually, whenever you do an application, you will have to redesign, re-architect that application so that few things are happening on the device, few are happening in the local edge, and few are happening inside the cloud data center. Like training the model, you may do it inside the data center, or sometimes you may do edge learning at the edge itself. So it depends on the application. things. And actually, when you see latency in devices, the latency is in 1 or 2 10 millisecond max, more than 10 millisecond in local edge. And cloud may take more than that. This is typically what happens, and it is about latency. So there are many edge computing applications possible in our smart city, making our cities and the nation smarter. Smart transportation, video analytics, healthcare, smart home, AR, VR, caching, and many more. Thank you very much.
Okay, thank you very much, Professor Rajesh Ingle, for your wonderful presentation. The floor is open for question. So if you do have any question to Professor Rajesh, you may ask. The floor is open for you. Please introduce yourself first, then ask the question.
Hi, Professor. Thank you very much for your nice presentation. It's really great to see that you're using, this is Faisal Hassan, and I'm an assistant professor of Bangladesh Institute of Bank Management. I'm working on fintech and latest technology adoption in financial organization of Bangladesh. And you're using two technologies, blockchain and edge computing, for enhancing a smart city. Actually, my question is very specific, that we're talking about a smart city, smart devices, smart homes, a smartphone even, and everything. We're moving towards a smart things. But the question is, do you think in a smart city we have a cyber security threat? And here, the awareness of the user, like in a smart city as user, how can we prepare our user in this smart city? That is my question. And if you show any framework or any kinds of guideline that how can we move to a smart city from a normal city, a pathway, that can be great in your research paper. So thank you very much.
Thank you very much. I think, Hassan, it's a very good question. But see, the thing is that, when you talk about the complete framework, actually, I mean, in India, we have got smart city initiative. Even IEEE has a smart city initiative. And as I said, the infrastructure first of all has to be in the place. Now, you just take the example. I'll just take that example and then come here. So whatever things card you swipe in Bangladesh, so earlier what is to happen is that it will go to the MasterCard and Visa card, which the servers are kept in Europe, right? The latency was little more, but now probably I'm assuming that like India, you already have a authorization servers in Bangladesh itself. So another thing, the edge computing, what it allows you federated learning without sending your data outside. So your data is within your boundary. So the attacks, number of attacks possible, because of actually you have privacy, the security is in place. And when you talk about framework, there are many frameworks available. Of course, even the definition of edge computing, people are debating. So the adoption of the framework will come in one of the standards. So what people are working on, including IEEE. And I think that framework is better that we follow that, because there will be argument even after that. And there may be improvement in that framework, what we are looking for. Another thing, when you look at the security issues, as I said, it will be there. Now, what infrastructure we have, it depends on what algorithms are implemented and actually what authentication mechanisms we are using. But today, in fact, if you look at our earlier security mechanisms, does not help us anymore. In last 2 years, we have seen that even if we have a tunnel, secure tunnel, the question actually is that all traffic is diverted to your data center and then back, and there is a big bottleneck of that. So because of it, the existing legacy security systems actually are not possible. So you need to go for GTA, that is zero trust architecture, and implementation of that. Like I'm naming few of the things, and if it is needed, I don't mind even talking about it. I'm working on GTA and SDP, software defined perimeter, and specifically implementation like SASE, secure service access edge. So we need to actually authenticate and authorize, subject and object in all the cases, and we cannot rely on. That is the aim of GTA, and that GTA architecture is available. Even if you search on net, you will get that. So it is a time, if you are having some plan in Bangladesh to actually plan for new architecture, it should be based on GTA like architecture. Thank you.
Okay, my session co-chair, Dr. Saiful Islam, he has some question. Okay.
Yes, Saifulji.
Thank you, Dr. Rajesh Ingle, Professor Rajesh Ingle.
You
For
may
your,
call me Rajesh also, that's okay.
for your great talk. So my question is regarding investment, because in our what I say, like developing countries or middle income country. So how can you, I just have one question, like in India, like what's the investment size in IoT based factory or IoT based companies? Like it's a physical item. I'm talking about physical things. It's not like a computing or any other thing. So what about I'm saying that mm, how can we attract the investors in our countries, like in India or Bangladesh, in IoT based factory or IoT based whatever? Do you have any suggestion for that?
Yeah, I think I understood your question and I think it is relevant. But let me tell you, IoT is actually allowing us to have some startups, because what is happening, because the open hardware ARM, because of ARM processors and nothing, we have got the open hardware solutions available. And because of that, what is there, you can actually, the startup can actually come out with some product which is need of a local community in your city. So there is a indigenous possibility of coming out with some indigenous solution in your area. So the thing is that if you ask me, I have seen, I think almost all companies are in IoT today, and they are doing wonderful work, right? It is not like somewhere in US, one product is developed and then it is replicated all over the world. No, that is not happening because of IoT. So that is one driving force what actually can be make use of. Another thing, if you want to really go ahead, you should look at ecosystem, generating ecosystem, meaning that if you look at IoT, then we need to tap nearby, maybe Malaysia, or maybe you need to have a fab where we actually chips getting generated, or the processors what you need getting generated. You need a company or you need a customer who has got requirements. So generating that ecosystem, what is necessary, and that is what my suggestion at almost all places. Of course, we cannot replicate what is happening in San Francisco or Bay Area. Ecosystem is different, but we have to come out with the ecosystem in every city of the developing nation. So there are many things which we need to answer locally. I'm telling very clearly, you go to the farms, there are simple sensors available. And that sensors, people are actually paying 100,000 times more than what the cost is, which you can do locally. And it is not rocket science. So why can't we come out with something which can be done locally? So that is something, the entrepreneurship and things when you start developing, then you will see the investment in that startup. And I'm telling you, there are many companies and many investors, venture capital VCs, ready to invest if they see a potential. First, we may target local market, and actually you start answering that, the local requirement. Maybe it is a ignition system of the scooter which is getting manufactured locally. Maybe it is a home automation system. Maybe it is a home protector, or maybe it is a simple, automation in the agriculture or in manufacturing industry, whatever things we do. Or maybe in the cloth or other thing, you may come out with something where the hardware and software and the solutions are required. So once you start tapping on that, it will get developed. It will not directly jump from 0 to 1. The life is not 0 and 1. This is what my suggestion from my side. Thank you.
Okay, thank you once again for your nice suggestions and answer to the question. So is there any more question from any? Okay, so you please give me a microphone. Again, please introduce and ask the question.
Thank you very much for your excellent presentation. This is Hassan Mahmood, Senior System Analyst, Bangladesh Agriculture Research Council. So my quick question is, you have shown that autonomous vehicle or self-driving car, one application for edge computing or something like this. So this is very much essential due to low latency application, because we know that it's low latency application. But technology is developing every day, right? So we are going for towards the 5G and even 6G era, and the backend bandwidth is also fiber, and even gigabit or 10G connectivity is also establishing. So what do you think in the future? Can we depend on the edge computing, or maybe cloud computing for the autonomous vehicles, or maybe something between, something fog computing or like that? Which one will be lead in this sector? Thank you.
Thank you very much. I think probably I could not cover that in more details. You said whether it is cloud, because if you see the last but one slide where I talked about, right? I had a cloud, then the edge, edge server, and the device. The thing is, in fact, you talked about also about autonomous vehicle. So if you see autonomous vehicle, and if you see the application of autonomous vehicle like Tesla or something is running in Bangladesh. Now, if you want to drive that, what will happen is that when I say it on one square, now I'm taking the decision whether it should be moved right or left. So it needs some processing locally, that is on device. I cannot send all the data to the cloud, deep inside the cloud, and expect them to process and send it back. Right? There is a delay, and that delay is not tolerable in case of autonomous vehicle. So without edge computing, autonomous vehicles at the high speed are not possible. Now, there are many applications I said are not feasible without edge computing. And like that, there are many such things, like where I am sitting right now, we have a Raipur. So we have all this smart city where we have all, cameras, all the places, and sensors, all the places. So now the smart city office over here is actually working on it. And we are doing some projects to see that how actually it can help people and the citizens. Maybe, there are many such applications. Okay, I think I may refer, not be exactly the same thing, but if I refer back to Large Hadrogen Collider project, you just see that LHC project, when the bosons was invented, is not possible without distributed system, because you have to sample it, process it, and give it back. So there are many such applications. I have given 3 different things, like which is require a latency, then bandwidth, and where you don't need human intervention, and autonomous vehicles are of that. And edge computing is something what is needed there, because you cannot rely on the data which is kept 4,000, 5,000 kilometers away from you. Because of law of physics, the latency will be there, and that latency will not allow you to have few applications. Now, the application is a big range, right? The moment you do everything on, not everything, whatever parameter, like if you have, suppose, just take an example in your university, if you want a firefighting system for the city. Now, if something goes there, you have to first see whether that fire is there or not. So local server, that device itself will do some processing. And then it will go to the local edge, and only the filter thing will go to the control center. Otherwise, if you dump all the data to this control center, they will not have time to process that. And even if they process it, right, it will be late, it will be delayed, and already the loss must have happened. So I hope you are getting my point, that processing locally in the device is the need of an hour. So processing, including your learning. So normally what we do, we actually put in the cloud, and we do train the model in the cloud, and then bring it onto the edge, and then start using it. But sometimes you may not have that much time also, because you need connectivity. So you may have to come out with, and specifically, Alexa, say all these different wake up words. They use TinyML. And TinyML is what actually is driven by edge computing. So like that, already there, you can just check how actually, even if you have robots in the manufacturing industry, or maybe at the hospitals, now that robot will have something, and if new objects is given, it needs to learn. That learning, if it is depend on in the cloud, you can think it will be dumb for some time. We have seen that maybe the paper and now robo from SoftBank, we have used it. And we realize that it takes time, because it needs to go to the cloud and do it. So edge computing in few applications is essential, and we are actually making use of it, and you have to actually go for it. Okay. Thank you.
Thank you very much for your answer. Okay, thank you.
Event happening at my university where people are there.
Thank you
also
very much,
stop here.
Professor Rajesh Ingel, for your wonderful presentation and taking part in the discussion session. So we have a token of appreciation certificate for your presentation. We will send you soon via email.